Today we're going to be talking about the laws of logarithms, and we're going to use those to simplify expressions and to expand expressions, and we're also going to learn this thing called change of base formula, and we're going to convert logarithms from one base to another. Alright, so the cool thing is there's only about 3 laws of logarithms that we need to be using when solving exponential equations and logarithmic equations. One of those is called the power property. Basically, if I've got an exponent, it comes to the front if I take the log. If I use the product property, it basically says, okay, if I've got multiplication inside of this log, I can break that up into 2 different logs that will become log with the same base. But then my m and my n get separated into those 2 separate logs. Alright, and the quotient property kind of works the same way. I'm going to be breaking up division into 2 separate logs. And then it's going to become subtraction. The way that I remember, hey, division becomes subtraction is that literally the division symbol looks like one big old minus sign. And it's always top minus bottom, just like with exponent rules. If you have division, it's always top minus bottom as far as exponents go as well. Alright, all 3 of these properties can be important in their own way, but the power property is probably the one that gets used the most, to be completely honest. It gets used every time we try to solve an exponential equation. We will try to use these properties in 2 different ways. One, today we're going to be simplifying logarithmic equations into one single logarithm, and we'll expand logarithms into expressions that contain only logs of single characters, which is kind of nice. Alright, so problem 1, we just need to simplify logarithms. We've got log base 4 of 32 minus log base 4 of 2. So the nice thing is they have the same base. And they've got a minus between them. Since we've got a minus between them, we're going to be using that quotient property, which basically says that I'm going to have log with the same base, which in this case is 4, of the first one is 32, so that's going to be my top, divided by my second one, which will be 2. Or I could just have log base 4 of 16, which is just 2, because again that turns into 4 to the x equals 16, 4 to the y equals 16, and that's just 2. Alright, on B we've got a couple different rules going on. The first one I need to be using is that power property, because I see something out in front. Alright, so that's going to change this into being log base 2 of now x to the 6th plus log base 2 of y to the 5th. Alright, not so bad. And then I've got a plus in between, which means I can also now use that product property. Since there's a plus sign in between them and I've got the same base, I don't need to change anything. So I would have log base 2, and combining those, I would get m times n. In this case, my m is that x to the 6th, times n, which is going to be y to the 5th. Alright, and then scrolling out a little bit so you guys can still see those rules at the top. I've got ln of 4 plus 2 ln of x, so again, I see, okay, ln is just a fancy way to say the natural log, and it's still log rules. I've got that plus in between, and I've got that 2 out in front, so I'm going to be using my power property first again. So then I should have ln of 4 plus ln of x to the 2nd. Okay, and then I'm just going to go ahead, and since they have the same base of e, should be just now ln of 1 condensed log using that product property of 4x squared. Alright, on D I've got all of my log rules. So I've got log of x minus 3 log of y plus 5 log of z. So again, the first one I'm going to use is that power property. I tend to use that one first if I'm going to have to use it, since I see numbers out in front. So I will have log of x minus log of y to the third plus log of z to the fifth. Alright, and I could have read those all as log base 10, but again, if I just write log, it should be assumed that it is log base 10. Okay, so the next thing that I need to do is I need to say, okay, well, which one do I want to do first? Well, when we get to just addition and subtraction, we just do everything from left to right. So the first one I see is that quotient property, which tells me I'm going to be having the same base, which is still that log base 10, or just log, of x now divided by y cubed, because m was x and n was y cubed in that particular case. And I've still got plus log of z to the fifth. Alright, since I've got that plus, now I should be using that product property, which tells me I should be having log of x divided by y cubed times z to the fifth, otherwise known as log base 10 of x z to the fifth over y cubed.